All right, we're
And we are
live.
live. Yeah.
Yay! All right, folks. We are going to have our first talk of the day. We have two talks today. We have Uri right now, and then we have Nir Kaufman in about 2 hours. And Uri is going to be talking to us about building high performance static websites with Angular. So Uri, if you need to share your screen or anything for slides or anything like that, go ahead and set that up, and we'll let you take it away from here.
Thank you. Well, I will share it in a moment. First of all, I want to say that I really recommend as well. Is really awesome and is also a very fun presenter. Anyway, so to our session today. So hi everybody. I see you're already very active at the chat, which is really cool. My name is Uri. I'm Google Developer Expert for web technologies for Angular, which means that I go around the world and speak about web-related technologies, also blog about them. I also work for BlackBerry. And today I want to share with you some problem that I had and the solution that I found for that problem. And while going through this problem, we'll actually learn a lot about how Angular applications are wired up and about some very interesting use cases, which are not the standard use case for Angular. So before we get started, I will quickly share my screen, and I will need to get your feedback if you can see the screen share. Mini tunnel of chat windows nested one into each other. If you do, please let me know in the chat so we can go on.
Yeah, we see it.
Hey, Shmuela. Okay, perfect. So I will start with the slides. So the slides for today is already introduced to you. We are going to see how we can use Angular to build high-performance websites, but not a regular website. Rather, we are going to build a static website. And for that, as I said, I will introduce you to a small problem that I had. So this used to be my personal website. And as you can see, it's not really up to date. I built it a few years ago, and it was all just one big HTML file. And I didn't really bother to update it. I mean, I write a lot of blog posts and I go to many conferences, but the recent Tech Talks section was not updated for more than a year. And the reason for that is that it was a big chunk of HTML file with a lot of repetition, and I never really felt comfortable with just going and updating a bunch of HTML whenever I had something new. It is 2017 now, and I'm sure we can do much better than a very big HTML file. So I set up on a journey to find a new way to maintain my website, and I had a few goals in mind. So the first goal was I wanted my website to be based on components, just like I build Angular applications, so that each section of the website is actually a component, and I can recompose the structure of the website just by moving components around. And then I can also repeat components, like create a component for a single blog post and then repeat it for each of the blog posts that they have. And then another very important requirement that I had, I wanted the content to load immediately. So I didn't want the user to wait once he enters the site. I wanted him to get the content instantly without having to wait for any JavaScript or to load and run. And then another thing I wanted is to have this really simple. I didn't want to run any Node server or PHP or any other kind of server-side solution. I wanted it to be totally static. And with that in mind, I started looking for different solutions. And you probably know, if you use GitHub, they have the GitHub Pages, which uses static website generator called Jekyll, which can probably achieve those goals. And there are other alternatives like Harp, which is using Node.js and the EJS templates. But I'm an Angular developer. I mean, that's what I do most of my time, build applications with Angular. And I would really like if I could solve this problem with Angular as well. Even though Angular is usually used in large scale apps that has a lot of code and usually a few minute more seconds of flow time, don't really make a big difference when you're about to work with some web app like Gmail for that will stay open. But in this case, I needed it to load real quick. So in this session, we are actually going to see how I built my own solution around Angular to enable me to get my website built with Angular while still getting a check for all those items. And throughout this journey, we're actually going to learn a few interesting things. So first of all, we are going to do it all from scratch. So we are actually going to see live how an Angular app is wired from the ground up. We are going to start even without an empty directory, because we are going to create a new directory and run all the different commands and create all the different parts and wire them together to get a functional app. And then we are also going to see how all the pieces are connected together in order to create an Angular application. And we are also going to meet a new tool called Fusebox, and also talk about Angular Universal, which we'll be using for the static website generation part. But let's start with the basic. So in order to begin, I'm going to create a new directory and use Yarn to initialize a new project. Yarn, if you don't know it, is just an alternative to NPM. You can pretty much substitute the command for Yarn with NPM, and it will work more or less the same. So let me switch to my window, and I'm going to create a Dev Summit folder, go into it, run yarn init -y, and as you can see, I got a package.json file that was created, something really basic. And now I'm going to install all the Angular dependencies. Basically, I'm going to install core.js and zone.js, which are just polyfills for features that will probably eventually make it into the browsers. And then Rx.js, which is a library for the reactive extensions for JavaScript, which is a library that is used by Angular to handle streams of data, like in the HTTP module. And then I'm going to install all the parts that make Angular, which are the core module, the command, the compiler, etc. And we are going to talk about some of those at Angular modules later when we get to configuring the app. So let's run this command, and Yarn is usually running much faster than NPM, so I expect this to install in like 10 seconds or so. Come on, Yarn, don't disappoint me right now. Yes. So as you can see, it's pretty fast. And once we are done with that, we will also install TypeScript, as we are going to use TypeScript for to write our code. So Yarn is still running. It will take it a few moments. And then we are going to add TypeScript into the project. And now the next thing, we are going to open the project with Visual Studio Code so we can start editing the code. So basically, we already got a very, very basic project skeleton, just the package.json and all the Angular dependencies. And the next thing we are going to do, we are going to create the actual files that will be the heart of our application. So the first of all, most important part, I will create an src directory, and I will put there an index.html file. By the way, I can't see the chat right now. Let me actually switch quick to the chat. Is the font size okay? Yeah, I see. Oh, thank you. So I see a few questions. First of all, yeah, you will have access to the presentation and the code and useful links. So thanks for asking, Don and Maddie. And Lars, thank you very much for your compliment about the Angular in-depth blog post. We have a new one coming soon, but I will talk about it in a few, and also about Fusebox. So just wait a few minutes and you will learn about Fusebox. But let's get back to the subject, creating the app skeleton. So let's create a really, really basic index.html. It will have HTML and body tags, and it will say hello Angular. Actually, you know what? Let's already create the skeleton for the Angular app. So it will have an app main tag that while the app is loading, will say, obviously, loading. So we have a really, really basic index.html. All it does, it says loading, and we still need to create the components for app main. And I think that's what we are going to do next, right? We are going to create the app module and the app component. So starting with the app component, I'm creating a folder called app. So this is basically the same folder structure as we get from the Angular CLI if you used it. And I'm going to create the app component TS. First thing, I will probably need to import the add component from the Angular core module. So I will import the component decorator, and then I can say add component selector would be app main. So this will be the main component for the app. Actually, let's also add some template. It will say hello Angular, and let's give it a class name, app component, I guess. Basically, we have got a really basic component. Don't worry about the TypeScript warning. It happens because we still haven't configured TypeScript with support for decorators, which we are going to do in a moment. But first thing first, let's make this template a little bit more interesting by adding some dynamic code to it. So instead of saying hello Angular, it will actually say hello, and then it will get a name from a variable in our component. And we can say hello to Dev Summit today. So yeah, that's basically it. We have a very simple component. We have a template and some data binding, so we can actually verify that this code is running, but we still have a few pieces to figure out before we can get this rendered on screen. So the next thing would be to create the app module. So basically, the app module is the main container that will include all the components and pipes that will get started when the app is loaded. We're going to import again from the Angular core, but this time we're going to import engine module. I can't spell. Okay, and then we're going to define the module. We'll call it app module. Not really creative with the names today. And we'll say that we want to the component that we just created, so that the app component will be available throughout the application. And then we also want to, let me see, we also want to bootstrap So we want to define the components that will get rendered as soon as the app is started. And that's, again, the app component. That will be the main component of our app. And finally, we also need to import a browser module. Let's import it here as well at Angular. So the browser module actually provide, why isn't it happy about it? Oh, it's platform browser. Yes, thank you, TypeScript, for letting me know. And that should be imports. I love that. Anyway, so the browser module includes all the functionality that is required in order to render the application in browser. So basically converting your template into DOM elements. And it also includes the command module, which is a part of Angular that defines all the command directives like ngIf, ngFor, and etc. So we have the app component and the app module, basically the two basic pieces of code that will form our application. And now we also need to create a main file, and this main file will bootstrap the application. So again, following the conventions of the Angular CLI, we are going to call this main PS and put it in the SRC folder. And basically, we need to import a function from the Angular platform browser dynamic. Basically, the platform browser dynamic is a module that includes all the code that lets you load components and templates dynamically into the browser and compile them inside the browser. So you don't need to run any build step process to build them during the build time. And we are going to import this platform browser dynamic. And we are going to call the bootstrap module, which basically gets a name of the module. And then this code should basically tell Angular, hey, I want you to create a new instance of this platform browser dynamic, and then use that in order to bootstrap my application. Last but not least, if you remember from the first slide when we installed the dependencies, we actually need two more dependencies, which are the polyfills for Zone.js and ES, and they're a part of Core.js, the Reflect polyfill. I hope I remember the name correctly. I think it's John.js this zone. So basically, Reflect is used by TypeScript for those decorators. So whenever you write a component, TypeScript actually generates code that interfaces with this Reflect polyfill. And Reflect takes notes about the properties of each of those decorators and associates them with the classes that you declare. And then Angular can ask Reflect, which does all this bookkeeping, hey, this app component, can you tell me more about it? Like which decorators did it have and what were their properties? So this is what Reflect does. And we only need it in cases where we use platform browser dynamic and load components in the template and compile them in the browser. If we do it on the service side or on the build time, as we'll do later, we can actually remove the Reflect part. And then Zone.js is another polyfill that makes Angular change detection work. So I won't get into the specifics, but you can find, I think, a good article about that in Angular in Devs or in Tortram blogs. So I think basically that's it in terms of code. Before we go forward and configure TypeScript and move on to the more interesting parts, let's see if you have any questions or things in the chat. Yes, so, oh, so many, thank you. Oh, Jared, you are following along with your PC. This is also exciting for me. I'll have to see. Regarding the extensions, I will show you at the end. If I don't, ask me again. I might forget. Anyways, so on to the next topic. And of course, if you have any questions, just pop them into the chat and I will check it after each slide. So we have the basic code for our application. It's written in TypeScript, but obviously this is not something that the web browser can handle yet. Maybe at some point, web browsers will be able to load TypeScript, and there is already a partial implementation of the ECMAScript modules in most of the browsers, like in the nightly builds and Canary versions, but this is definitely not something we can work with right now. So the next step would be, first of all, to configure TypeScript. So it will translate those TS files into JavaScript. And then we'll see how we actually bundle them together so that they can be loaded into the web browser. So the first thing we're going to do is to set up the configuration for TypeScript. And for that, we're going to create a tsconfig.json, which contains the configuration for the TypeScript compiler. Here it is. And I'm actually going to cheat a little bit here. Just to use a snippet for that, because I don't want to remember how to type all of that. But we'll go over this configuration file quickly. Basically, what we say, this is the output directory where the compiled code will go. Module CommonJS is the module format that we'll use for the imports and exports. I will show you the result, what it looks like in a moment. Module resolution node tells TypeScript to look for modules that you import inside the node modules directory. And then if you remember, we had this annoying warning about decorators is a feature that is blah, 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 blah. So these two options actually enable decorators in TypeScript. So I think I need to reload my Visual Studio Code for the warning to go away. We'll try it in a moment. And finally, there is this lib, which says we are going to use ECMAScript 2015 and all the dumb functions like document query selector, location href. We also want them to be available to us in TypeScript. So basically, that's it for the configuration. Let me quickly reload the window, so hopefully those errors will go away. And then the next step we are going to do, we are going to set up TSC. TSC is simply the TypeScript compiler. And first of all, let's see. Yes, we no longer get those warnings about decorators. So I'm going to add a new npm script that will call TSC. We'll call it build, and it will run TSC. So basically now whenever I run npm run build, it should build my TypeScript code and write it into the this directory. So it worked. You can see that I have the exact same structure as in SRC, but I have the files compiled from TS to JS. And if I go into the file, I can actually see it replace the imports with a require statement, which is CommonJS syntax as we specify in the TypeScript configuration. So basically, right now, we already got the all the application code in JavaScript. Doesn't look as pretty as it used to be in TypeScript, but this is finally something a browser can digest. Even though if you see, we still have those require statements, which are not really supported by our browser. So in order to handle those require statements, we need something that will handle all the module loading. And there are a few alternatives for that. The common ones are System.js and Webpack. System.js was used by the Angular CLI, I think, until beta 12, and then they moved to Webpack. So now they are using Webpack. But for the sake of this talk, we are actually going to use a different tool called Fusebox. I will install it, and then we can discuss some of the advantages of Fusebox, and I will even show you some of them. So basically, Fusebox is another bundling solution like Webpack. It just takes all of your modules, in this case, the JavaScript files that we have seen, and their dependencies like the Angular packages, and it simply bundles them into a one big or several big JavaScript files. So basically, the same as Webpack does. But it has two advantages that I really like. First of all, it's super fast, and you will see in a few moments how much fast it is. Like, it's really fast. And then it also got hot module reloading out of the box, which is also cool. So you don't have to wait for your page to reload whenever you make a change. I will show that to you once we get it set up. And then the configuration is also simpler than the one that Webpack has. Yeah, let me just create a configuration file so you can see it. And finally, it also has built-in TypeScript support. It comes with TypeScript support out of the box, so you don't have to set up anything before you just use TypeScript and it works. Before we move on to configuring Fusebox, let me take a quick peek at the chat. Yes, I use Wallaby. Good guess, but let's get back to Fusebox for now. So let's set up Fusebox. We need to do two things. First of all, we are going to use create the configuration file. Oh, I got a snippet for that as well. Cool. So basically, the configuration file imports Fusebox. It says, hey, I want to read the source files from the src directory. I want to write the output to the dist directory. And then I also need to include a few helpers that are functions that TypeScript use. So this includes them in the bundle. Then I want to run the dev server on port 4445. I have no idea why I chose this number. And then I want to create two bundles. One will be the vendor, one will be the app. And I can figure how Fusebox works by just chaining those function calls. So I want hot module reloading, and basically this tilde sign in main.ts says, I want you to take all the dependencies of main.ts, all the external dependencies, and include them in this bundle. And likewise, we have the app bundle that will basically include all the things in main that are not external dependencies. And we are also going to watch them. So whenever they change, the app will reload. There is no point in watching the third-party dependencies. It will just slow down things. And finally, we call fuse.run to start Fusebox. And in order to be more efficient during development, we are also going to create an npm script called start that will just run this Fusebox configuration file. So unlike Webpack, which provide us a CLI tool that we run and it loads the configuration file, with Fusebox, we simply write code, run that code, and that code bootstraps Fusebox. So a slightly different approach, but I think this format looks much clearer than Webpack configuration. And then let's start this. So I'm going to write npm start, and we are going to see if it worked. And it's all ready. So quick spoiler, I'm going to open this URL and it's not gonna work. Let's try that. Yep, can't get slash, because Fusebox is actually serving the dist directory, the output directory, and we don't have any index file there. But you can already see that the app.js bundle and the vendor.js bundle were created. So it basically works. We just need, for the time being, to copy the index.html file manually to the dist folder. And the reason for that, Fusebox does provide a way to do that, but we are going to do it a little bit differently when we generate a static website in a few moments. So let's do it manually for now. So basically, what we are going to see now is loading, and if everything will work, it will quickly change to hello Dev Summit or whatever we had in this component. Yeah, it would say hello Dev Summit. So are we ready for this? Are we ready for this? Let's find out. It's loading, and it probably had some error. Oh, obviously, I have this HTML, but I forgot to load main.js and vendor.js. So let's add that as well. We have vendor first. And then we also want to load was app.js. Okay, so now we are all set, and hopefully this time when I click the link, we'll actually see hello Dev Summit and not just loading. Let's see if it works this time. And still have some issues. Let me see. Oh, of course, I didn't copy this to dist. Oh, trying for another try. Let's hope this time will be more successful. Yes, it worked. Hello, Dev Summit. So yeah, we finally have, it took us 30 minutes, but I also had to explain you everything. We finally have the Angular app that we configured totally from scratch, load and run inside the browser. And before I show you how fast Fusebox is, which I think is one of the coolest takeaway you are going to get from this talk, let me real quick check the chat to see if there are any other funny things. What about the Angular CLI? So about the Angular CLI, I hope that they will adopt Fusebox at some point, and I think that they are going to at some point enable build time rendering, which is the thing we are going to add next. So I hope that eventually you will be able to do everything that I present to you here with the CLI, but it's still not there. Anyway, we got Fusebox ready, and now I even spelled the Zone.js and Core.js polyfills correctly. And now I'm going to show you some of the Fusebox wonders. So I have my component on the right and the Dev Summit and the app on the left. And I'm going to change the code. So instead of hello Dev Summit, it will say hello dear people, because that's what you are. And I'm going to hit save now. Have you seen that? Like a split of a second, and it reloaded. And I can do it all day. I don't have to wait. The second I save, I get it hot reloaded and re-rendered on the left side of the screen. So I think that's really amazing. 49 milliseconds to re-render the app. And I tried it with larger apps, and apparently it still works pretty well. You get under 200 milliseconds for every change that you make, in contrast with Webpack, where I could get down to 2 or 3 seconds, but it still doesn't feel as immediate as in Fusebox. So that's one of the main reasons why I love Fusebox, and I recommend that you check it out. So before we go on with the build time rendering, let's see if you have any comments on the chat. Yes, so Fusebox has a built-in dev server, and yeah, sweet. This is so cool, nice, awesome. So I'm not the only one excited about Fusebox. That's cool. And then, So how does Fusebox handle a larger code base? That's a good question. I haven't tested with humongous code bases. I did test it with some larger projects, and it worked pretty well. Like, it wasn't 47 milliseconds, but it was like 150, 200 milliseconds, which is still pretty quick. There are a few issues if you use a lot of Webpack loaders and you want to migrate to Fusebox, then you will have to find ways to configure Fusebox to behave similar to Webpack. So the setup could take a few days for existing projects, but then I think it's definitely worth it, especially for newer projects. Anyway, about the dev server, it has a built-in dev server, and you can see that I enable it here in line 9, where I say fuse.dev and give it the port number to run on. So that's it about Fusebox, and let's get to the second part, where after we have set up our development environment, we are going to set up the production environment. So we are going to build the static website out of our app, because right now, you know what? Let me show this to you. If I simulate a real slow connection, like a fast 3G, even a faster connection, and I reload, I notice that the user sees this loading for like already 5, 6, 7, 8, so many seconds. It's 10 seconds and it still hasn't preloaded. So, yeah, like 12 seconds until the user sees this greeting. So it's definitely not optimal, and my goal was to get a user to see something immediately. So let's set it up. For that, we're going to use a project called Angular Universal. It used to be a community project, but now it's part of the Angular platform. And it's also called OTB, which means outside the browser. I actually used Angular Universal for a very unique use case, but I will tell you more about that in a moment. First of all, Angular Universal allows us to run the Angular framework in a different environment at the browser. So that could be on the server side or on any platform that can run Node.js. So in one of my projects, I actually used Angular Universal on a Raspberry Pi to control a Simon game that was connected to physical hardware. So that was Angular, instead of running inside the browser, running on an Internet of Things device. You can actually find me if you look for Angular IoT on YouTube, you can find this talk as well. Anyway, another thing about, so we are going to use Angular Universal to render the pages, this index.html, during build time, in contrast to rendering it inside the browser. And for that, we are going to need to add a few more lines of code to our project. So first of all, we are going to create a new module that will be used to bootstrap the application when we build it with Angular Universal. So we are going to create a new app server module. Let's go back to the code and let's create a new module, new Angular module called app.server.module.ts. And this one is basically, actually I'm going to be lazy and copy paste from app module. This module is basically going to bootstrap the app. I'm actually going to inherit all the stuff from app module, so I don't have to define everything again. Let's call it app server module. I still need to redefine my bootstrap component, because the bootstrap component is only relevant for the specific module I'm in. It's not getting imported by the import. But then other than that, I also need to use the server module, which allows me to run Angular on the server. So I will import it, server module, And I think that's it basically. I now have this app server module that I will use in a moment to bootstrap the app during the build time, so I can pre-render it. So one more thing I need to do, I need to go to my app module and do a little bit a small change. You see this server transition. So I need to add this to my browser module, which basically tells the browser module, oh, I need to give it some app ID. I haven't figured out what's the use of this parameter, because whatever value I give there, it works. Basically, this with server transition tells Angular whenever it bootstraps the app, it says, I want you to go over the HTML document which has already been rendered and take control from there. So in this case, Angular won't see our index HTML with the app main that says loading. It will already have all the content and components there. And this with server transitions tells Angular, I want you to take control from whatever the server rendered for you. So that's it. We have all the code that we need for the server-side rendering. Well, except for one part. We need some code that will run Universal and render the index HTML time on build time. So we are going to create a new script called build. Let's do that. Build.ts. And this script is going to use a part of Angular Universal that is called a method from Angular Universal that is called render module. This method takes a module. We are going to take the app server module that we just created. And it also needs a document, an HTML file it can work on. So let's load this index HTML file, import start request from us. Then we can read the HTML file. So this code I'm writing right now will actually run inside Node in build time, and it will bootstrap Angular, read the HTML file. We need to string it, I guess. Yes, now TypeScript is happy. And then if I hover render module, I can see it actually returns a promise. So I'm going to call then and get a result and then print it. So what it will basically do, it will read index.html and create a new HTML file with all the dynamic content inside the app main element replaced with the actual text. We'll see it in a moment, but we still need to add the same polyfills as we have in the main file. So these are the polyfills that we use for the browser, and those reflect and so on don't exist inside Node as well. So we are going to need to import them here. So Node can use them. And unfortunately, Node still can't run TypeScript files, but we have a nice NPM module for that called tsnode. So we are going to install it and create a script that actually, let's replace the build script so that it runs this build.ts file with tsnode. So this tsnode is basically an NPM module that gets a file name as a parameter and loads it in Node, but it also transpiles the TypeScript code during this process. So I think finally we are ready to run our build script, and if everything goes well, we'll get the index.html printed to screen, but it will be the content will be replaced with the actual contents of the index file. Before we do that, let's see real quick if we have any questions. Thanks, Lars. Good note. That's sick. I love it. Well, I enjoy reading your comments. But anyway, let's get back. Let's make it even more sick. So running Universal. npm run build, which is supposed to run this script. And let's see if it works. Waiting for the promise, waiting for the promise. TS node, compiling, running. Yes, it worked. As you can see, it actually created, so we have here the index.html file, but it replaced the contents of app main with the actual contents of this HTML file. So basically, Angular ran inside the inside this node process and render the page. And we still need to write this to the disk, so we are going to use write file sync. And as I told you, this process will create the index.html in the disk folder. Write file sync, and we need to give it a result. So now when we run it again, it will actually write the index.html file into the disk folder, and we can see that now we have this HTML file with the pre-rendered content. So basically, we achieved our goal. We got build time rendering, and then we still load Angular. So at some point, Angular does take control. Let's actually see this in action, how Angular takes control. So let me see. We have this browser here. And as you can imagine, now it writes, you can see hello, dear people. Let's actually refresh from blank. You can see this hello, people immediately before the script loads. But as soon as the script loads, Angular will take control and the page will also become interactive. Let me show that to you by adding some simple logic into my component. So let's add a button and say on click, we call the change name method. Change name. And then here we'll define this change name method, which will say this name equals awesome works. And now if everything goes well, let's reload it. So, oh, I need to rerun the field to re-render the server-side code. Yes, waiting for it to run. Yeah, it ran. So if we reload it, we can see that we have the change name button. It's not active yet. It doesn't do anything because Angular hasn't loaded. But in a few seconds, once Angular will load, if I did everything right, we can see that it says how awesome it works. So basically, Universal rendered the HTML with the button and the text. And once Angular loaded, it took control, and then the page becomes interactive. So any questions or cool comments up to now? Very cool. So, assuming that Fusebox and Universal behave the same with templates defined written in external files, that's a good question. I have a slide on that in a moment. So back to the slides. Basically, I had a problem of getting my website written with Angular, so it will be easy to update. And fortunately, this problem has been solved to me. And now, if you go to urish.org, you can actually see my new website. Oh, you can actually see this Angular IoT project I told you about earlier here, which is rendered at build time. Whenever I deploy this, I use Firebase hosting for that. And I can write a code using Angular components, and actually all those hardware projects are pulled off from a JSON file, and I have an Andrew repeat that creates those blocks. So basically, the problem was solved for me. Now, whenever I need to update my website, I just fire up Fusebox, hack on it until I'm happy with what it looks like, then run npm run build, npm run deploy, it uploads it to Firebase, and you can see the result. And I actually update it now much more often. Whenever I have a new project or a new blog post, I just go there and update it because it's much more fun than it used to be. now with Angular. So what's next? What can you do what can you explore even further to make this more fun and useful? So first of all, of course, once you got a static website, make it look awesome with CSS and add some cool interactions. And then you want to deploy it. So you can use Firebase hosting, GitHub pages, or there are plenty of services that let you host static websites. And then once you deploy it, to answer the question from the chat, there is a nice plugin called NGT Fused that sets up Fusebox to load templates and styles from external files correctly. So definitely check this out if you are going to use Fusebox for a more serious projects. Furthermore, you can also set up ahead of time compilation. So the bundles that you ship to production are not so big. So even though we have instant loading of the app because we build it during build time, we render it during build time, the user still has to wait for the JavaScript files to load if he wants to interact with the site. And AOT ahead of time compilation will remove all the Angular compiler from those files and make them much smaller. So the interactive part of the app will also fire up much faster. And I will share the slides with you. You can click on this AOT words to watch a talk where I explain how to set up AOT and the advantages of AOT and what AOT actually is. And finally, there is another cool tool that you should check out. It's another project from the Angular team called Preboot. And if you remember, so when I loaded a page, if I click change name now and wait until Angular is interactive, I will notice that Angular didn't catch the click for an obvious reason. It should be interactive now. Yeah. So Angular loaded, but I clicked before it loaded. So Angular didn't register this click and didn't handle it. If I click now, it will obviously work. But in an ideal world, I would want the Angular to know that the user interacted with the page in some way before it loaded, so it could handle these interactions as soon as it has been loaded. And that's exactly what Preboot does. It adds a small snippet of code, of JavaScript code at the beginning of your static HTML file that records all the user interactions. And then when Angular loads, it actually replays all these interactions, and Angular can handle them. So for the user, it feels like it took a little while for the app to load, but the app actually responded to the user's interaction. And you asked me about the code. So all the code is available on GitHub, and I will post this link and also the link to the slides on the chat. But first of all, let me take a sip of water and see if you had any questions. And another note, at the end of the slides, after these key takeaways, there is another bonus, 1 or 2 bonus slides. So check out the slides after the talk and look for the bonus slides at the end of the slides. So a sip of water. And to summarize what we learned today. First of all, wiring Angular yourself is not that hard. I know that the CLI can do it for us, but I see a lot of value in understanding how everything is put together. So if you need something unusual, such as static build time rendering, it's actually doable. And then Angular Universal enables new interesting use cases that were not possible before with AngularJS, such as, so one of them is build time rendering, which is very useful if you have a blog or a marketing site or documentation site or everything that has a lot of content and doesn't require very heavy interaction. And then also the Angular IoT project that I mentioned, running Angular on a physical devices, that's another cool use case. So definitely explore the new directions and opportunities that we get now with the new Angular framework and Universal. So the last thing I want you to take away from here, Fusebox is really nice. Do check it out. Try to use it. I would start with a smaller toy project to see how it plays with all the other parts of the ecosystem and to get a good taste of what is it like working with Fusebox. And I hope that eventually it will also become an option in the Angular CLI, because as you have seen, the experience is much better than Webpack. So thank you for listening. I will go for the chat for the last time to see if we have any questions. Oh, wow. Wow, thank you. So, wow, I love reading your comments. Applause. Don, I see you have a lot of questions, so let's take them to the chat, because I would really love to answer everything about testing and yeah, I'm not sure. I don't have time to demo that at the moment, but yeah, for the external templates, I also use them in my project. Just set up the ng2fuse plugin. It's actually one of the bonus slides that I have here at the end of the presentation. So just set it up and it should do the trick. Let me share the link to the presentation with you and the GitHub repo. So this is the GitHub repo.
Yeah, I've got to push us to wrap up. I've got something scheduled here at noon. So.
Okay, perfect. And I'm just done. So yeah, so now you have the links to the GitHub repo and the slides. It was really a pleasure. I really enjoyed reading all the comments in the chat. And don't feel free to reach out to me in the speaker channel, in the conference chat channel, and I would love to answer your questions. So goodbye, everybody.
Thanks, Uri. Okay, we'll be back in an hour. Bye.